Okay, 2.3. There was questions on some of the problems here. First of all, number 1. Number 1 said the interval 2 comma 5 can be written as an inequality, and that would be 2 is less than, that's not including, x, which is less than 5, and that's not including, a square bracket would be including, so there's no equal, so that would be the inequality. That's number 1. Next one is number 4. 4, write the point slope form of the line with a slope of 5 and containing the point 3 minus 2. So y minus y1, which would be minus 2, equals m, which is 5, times x minus x1, or this point, which is minus 3, and that would be the point slope. This we would change to plus a positive 2. So it's y plus 2 equals 5 times x minus 3. And that's the point slope form. 5. The intercepts of the equation y equals x squared minus 9 are. So if we want the x-intercepts, we let y be 0. We get 0 equals x squared minus 9. We add 9 to both sides. And we get x equals plus or minus 3 when we take the square root of both sides. But then we have to write intercepts as point. The y was 0 and the x was 3. Or the y was 0 and the x is minus 3. Y-intercepts. And that would be when x equals 0. If we put 0 in for x, we get y equals 0 minus 9. So writing that, we've made x be 0, which means the y is minus 9. So there are the intercepts, the x's and then the y's. Next one is 35. 35. Let's see here. 35 is a graph. I'll move it down here. 35. I'll kind of quickly sketch the graph that's in the book. And this looks like a sine curve that goes through minus pi. But you may not know that until you take 154, and this goes through minus pi over 2 negative 1, and this goes through pi over 2 plus 1, and let's see. For the function given, find the graph. The numbers, if any, in which f is a local max. And this continues on doing this pattern, but we don't know that for sure, so we're just going to go by what we have here. The numbers, if any, which x is f is a local max. Local max is the highest place, and it looks like we got one right here. So that would be, it's a local max of 1, and it happens when x is pi over 2. Turns out this will also happen here at 2 pi further, which will be 2 pi plus a half a pi is 2.5 pi. Well, then it'll happen at 4.5 pi, 6.5 pi, 8.5 pi. It'll be 1, and that's the maximum value, and it happens there. And then it says it's a local min. and that would be the height. The lowest height here is of -1, and it happens at, according to this graph, x equal -pi/2, and it will occur also 2 pi further, repeatedly 2 pi to the right and to the left, added on or subtracted off of that. But these are the only ones that are shown in that picture, 35. So that's 35. Now we'll go on to 37. And 37 says f of x is 4x to the third, and determine algebraically whether the function is even, odd, or neither. So to do that algebraically, we put in -x into f of x and see what happens. So if we put -x in here, we get 4 times -x, replacing the x, cubed. Well, a -x times a -x times a -x, 3 negatives will make, multiplied will be still negative, and so that could come out and be -4, and x times x times x is x to the third. Because this is -1 times x to the third, and we can, when they're multiplied, we can send the power in, so it would be -1 to the third and x to the third, and -1 to the third is still -1. So -1 times the 4 is -4. So what happened here was we put a -x in for all the x's, and we got not 4x to the third, but the negative of what f of x originally was. And this is what the definition of an odd function is. If you put in the negative of the x, you get negative of the original function. So this is odd. If you change the sign of the x, you get a change in the sign of the y. 37. And I think there's more of them here. 39. That people will have question on. 39, g of x is -3x squared minus 5, and so we will again put in -x and see what happens. So g of -x will equal -3 x quantity squared minus 5. Well, since this is -1 times x and we square it, we'd have -1 squared and x squared. -1 squared is +1, so this is the same as plus just an x squared. So because this turns into 1 times -3, so we get -3 and the x squared minus 5. And we got back, by putting in a -x, the original function. And the definition, f, when we get x, we put in a -x and we get the same function back. That's the definition of an even function. So 39 is even. 37 was odd. Next question was 47. 47 is another one of these, and h of x was -x to the third over 3x squared minus 9. So we'll put into h of x, we'll put in a -x, and so this becomes, we have a negative, then in place of the x, we're putting a -x to the third, and we have a 3, and in place of the x we're putting a -x, and this turns out to be -x to the third. The -1 to the third is -1, so I'll change that to plus, and x to the third. And -x times -x is +x squared, so this becomes 3x squared minus 9. And if we look at this and we look at this, there's a sign change. This part is exactly the same as this. Then putting in the negative changed the sign of the total function, and so that matches the definition of an odd. If you put in a negative, you get the negative of the original. If you put in a negative, you get the negative, the opposite of what the original was, and that's what we got. So this is an odd function. All right, stop that video.